so I'll make this quick, but this is all the tube we bought, and we went and labeled everything, which ones. So like in the diagram, some of these are bar B, C, or D. And we went ahead and labeled like the dimensions, which these are 1.5 inch, all the others are 1.25 inch. But the wall thicknesses are really close. You can see these tubes are 0.65, that's 0.58. That's only a 7th thou difference. And here they're the same diameter, but it's 0.65 versus 0.58. So we measured all that and labeled it. And one thing we did, this is just one of those things when you're doing fab work and you're buying raw materials and stuff, these are all nasty when they come in, and if you leave them like that, whenever you weld, it's not going to be as good. You're going to get crap all over you and spread the dirt. So what I did was when I pulled this off the rack, I just grabbed some white rags and acetone, gave them a good wipe down a couple times, and I also deburred these edges because they're all saw cut, which, you know, leaves like burrs and sharp stuff. I don't want to get cut. So they make this little deburr tool. These are only like $10 and they're awesome. You can basically just spin this around the inside of a tube and it cuts all the burrs out for you. So get those cleaned and deburred, and that's important. That way we don't get cut and we can keep our workspace clean. So just a little important thing for you guys. Okay, so we're working on that shoulder bar, and we had talked about using a right angle tool to do our marks. Well, we just used a regular piece of metal, but that totally worked. So we got 2 marks, and all we did was throw a tape measure across and get the difference between them. And that gave us 43.95. So what we can't do is cut a tube to that distance because we still got to cope them. But that's the distance between the copes, or the notches, or whatever you want to call it. So with that in mind, we're going to go mark these at 43.95, but not cut it yet. And then we'll use our notching tool, which we got to get set back up in the vise. And we'll use that to cut our 2 cuts, and basically it'll intersect at that line. So that way the edges will actually be longer. And of course the edges will poke into the cage, or this hoop, like this. And then we can make sure it fits good, and then we can tack weld it in place. Okay, so we're going to try to record this. This is doing the notch for the shoulder bar. So I don't know if this shows up in the camera, maybe it does, but we set this back to 90 degrees. So we're just notching it straight. We got our 1 5/8 cutter in here, got our tube marked. I'll show you in a minute, but we put a line on the tube so that when we do this notch and we flip it around to do the other, that these are parallel. That's kind of important. So we did that. So now we're going to take some of our oil and just put a little bit on this cutter. Like that. Throw a little bit on the tube. And here we go. Hopefully this goes nice. So I'd say that went mostly okay. I think we missed our mark a little bit. We are going to check it with a tape measure before we do the second cut. I think we overcut, so our mark is gone. That orange line is the line I was talking about that extends the length of the tube. This is where we were going to cut it, but we're going to check that measurement before we do the next one. And this should be fine, but let's make sure this actually fits the tube like it's supposed to. Let's see. Oh yeah, that looks good. There's no problems there. So we'll check our measurement, flip it around, cut the other side. I will add one thing. So this notcher was like 500 or 550 bucks. It was actually pretty expensive. They made cheaper ones, but a lot of them had less features, and primarily they were less rigid. So you note when I cut that, there was a little bit of shaking, but overall, I mean, that cut pretty nice. And the reason is this is a beefy setup. So all this steel, that is at least 1/4 inch thick, maybe thicker. That's some beefy steel. And you can see pretty much everything, the jaws, the frame. I think pretty much every single piece of metal on this is that thick. It's just a beefy thing. It's got cam locks top and bottom to lock those together. This arbor This shaft is like 1 inch thick and it's got bearings on both ends. So this rotates, like, even though this will slide to do the cut, the support is actually pretty decent. So, you know, it's got a little vise. This vise ain't the best. I've had that come off before, but overall the build quality is really not bad. So it's one of those things, having the right tools does help. I'm not rich. A couple of my friends think I am, but I'm definitely not. I work hard for my money for what I do have. And this was a tool that I've been on both sides of this. So when I was in school, we had a race team and we actually had some tools like this for notching tubes, but sometimes we didn't, or I guess in the beginning we didn't. And you would just basically mark the tube with a Sharpie and then grind it. And I've done a bunch of them that way. And you can actually get them pretty good. It takes a little practice, but once you know what you're doing, you can grind these and they actually turn out pretty nice. The hard part is getting that pattern. So what we did, we used our CAD software and we would basically go through step after step of creating like a thing wrapped around a tube and print out the profile and try to get it to scale correctly and then wrap it around the tube. And if you finally did all that and then you cut the shape out with scissors, like, I don't know if this makes sense, but it's basically like creating a sticker that you can wrap around the tube and then it has the right shape and you can take and transfer that shape with a Sharpie. That did work, but it was so time consuming. Like, you know, you could literally spend an hour to do a tube, sometimes 2 hours, just because it took so long to create the patterns and then make sure they actually wrapped around the tube correctly and everything fit and scaled. Because you'd go to print it and it would be like 5 or 10% off, and that would be a problem. So anyway, point is, you can buy cheaper ones. So my recommendation would be, if you're going to have to do stuff like this, like if you're just doing a couple parts, yeah, just grind it. But if you're going to build like a cage or, you know, fabricate your own control arms or some crap like that, at least buy a cheap one of these. I think they make cheap ones for like $100 nowadays, maybe 200, and it's going to be way better than having nothing. Basically, when they don't have rigidity, you got to go more careful. So I did that whole cut in one shot, and I never stopped and added oil, which basically I got away with it because this is just a little pipe and it just wasn't that bad to cut. But it wouldn't have hurt to add a little more oil. That's one of the things with these cutters. This one's still sharp. It's cutting great. And that's because I'm not overheating it. Like, if you look at the color of the metal, it's not discolored. Like, you can see the teeth for the 3 people that are still watching. But, I mean, there's still paint on that. Like, it's not overheated. Now, if we go to this one, this thing definitely overheated. You can see there's teeth broken off. This has gotten way too hot. And I was spinning this really fast, and that's probably why. The instructions said to just go with it. And admittedly, if you squeeze the trigger back and just let it eat, yeah, it cuts quick, but they sure don't seem to last long. So my theory this time was I was going to use these cutters and basically follow common sense, which common sense says to kind of go slow, light pressure, keep it oiled, you know, don't let it chatter, all that kind of stuff. So we've been doing that and we've been getting good results. So just thought I'd show you guys that. I guess the last piece of the puzzle is the drill. I happen to have a good drill. For you guys that want to, like, so if you're going to do a lot of fab work, you got to buy tools like over time. So I've had this drill for years. I bought this drill probably in 2012 or 2013. So I mean, this drill is almost 10 years old, but it's a good drill. It's a whatever. I'm not going to go into like a whole story, but basically this drill has a ton of power. That's actually the real reason I bought it. If we come over here, you'll see it's a 10 amp drill, and it'll actually go up to 3,500 RPMs, which is really fast. And it happens to be a hammer drill. We obviously don't need a hammer for this, but the point is, this thing will do 1,200 RPMs at 10 amps. So that handle on there is really not optional. This thing will about break your damn arms. It's got a lot of torque. So that helps with stuff like this. Like, I could, you know, when I was doing that cut, you guys probably saw me, I was probably like this. That's basically that's the minimum speed in low. It'll go a lot faster. I just wasn't using all of the available power. And that's nice because I basically just barely squeeze the trigger, the motor turns on at low speed and low gear, and just slowly chew through this thing, and it's got so much torque I didn't have to really do much. So, you know, and the thing is with a drill, it works good in this tool, but this works good in pretty much everything. It's always nice to have power. So anyway, a little tool thing for you guys.